Hello everyone. I am Pushpita Chanda. So I am taking this class for week 2. Due to some personal commitment, I could not take class last Tuesday. So am I audible? I want to to tell you that if this call get disconnected after 1 hour, please remember this link. You need to join via this link on after that. Week. I'm taking the class late, so I think that people have already submitted the assignment, and other tier has uh, explained the assignment, I believe. So let me uh, explain some other kind of examples, uh, which are like inconsistent with this subject. So, firstly, I want to write the equations we are working with. So we know force is equal to mass into acceleration. This thing can be written as dv dt m d square r dt square. If here the condition is this is constant. If m is not constant, then dt we write this way. So that goes p. P is linear momentum. M and V. And also delta P, or the change of momentum, is equal to F into delta T. Basically, this is F net. This is also called impulse. So delta P is basically That has already explained two example, uh, and one of the question in the assignment is exactly same like one of the example. So acceleration is basically force by mass. From here we can know many things. If we know what is the force and the mass, we can know the acceleration. From acceleration we can know the trajectory. Acceleration and mass, we know function if if is a function of position or if is a function of time. We can obtain all of those things. So let's start with some example. Also, professor also has said that fx can be written as, so in that scenario we know f is md square r dt square, d2 or dt2, not square. This is called second order differentiation of the position vector, because f basically ma acceleration. So fx will be m d to x dt2 x cap plus m d2y dt2 y cap plus m d2z dt2 z cap. So basically fx is equal to m d2x dt2 m y is equal to m d2y dt2 plus sorry, the z component of x will be f d2z dt2. Why this is like this? Because r is equal to x into x component plus y into y component plus z into z component. Usually we denote like this. So d2r dt2 becomes m dt2. R is unit vectors, doesn't depend on the t. So that's why you can write this that way. We need to remember all those things. First example is figure the tension stick stream is T when all the surfaces are frictionless. If 2 kg block is glued to the surface, the tension in the string will be A 0, B greater than T, C less than T, D equal to T. So the figure is this. Okay. So this surface and this surface are frictionless. And this thing is 2 kilo. This box is 10 kilo. So the question is, the string, the tension in the string, what will be? Surfaces are frictionless. So now we need to know that what are the forces acting on each box. That's the way we solve every mechanics problem. So this is the 10 kg box. We know tension is upwards here. So this is 10T. There is acceleration working or gravity working in the bottom. So A. And there is weight. Weight, what is weight? M into G, which is, because this box is sliding, so there is acceleration, but this box also has a weight, which is M into G, which is 10 into 9.8. For 2 kg box, T at this its acceleration is also A. If this box is falling, this box is also going this way. For this box, this is T minus G is equal to, so let's see, we need to equivalent. So T plus MA is equal to MG. So MA equal to MG minus T. So 10A is equal to 10 into 9.8 minus T. Okay. And from here we can see that tension causes the acceleration. So T is equal to 2A. To 9.8 minus 2A. It will be 12 10 into 9.8, basically 10 into 9.8, right? 12. Okay, so this will be 5, this will be 6. 16.33. When 2 kg is glued, action is 2 kg is glued. 1 kg will also be at rest. So here it will work T dash, and here it will be its mass. So it is 10 into 9.8. So T dash will be 98 N. So in previous condition, what is the condition? That it is frictionless. So the masses were moving due to T. So in that case, the T is 16.33. But when the 2 kg mass get fluid, then T dash, the string tension is 98 N. So we can say that the tension in the string be greater than T. Example 2. A block of metal weighing frictionless plane. If it is struck by a jet releasing water at a rate of 1 kilo per second and at a speed 5 meter per second, calculate the initial acceleration of the block. So now, um, say this is 2 kilo. This thing is at rest. Because the water jet releasing water at that weight. So the dm is g per second. So it is basically dm dt. The block is itself 2 kilo, and the if the water is coming from this side, the acceleration should be in that side. So if we know dp dt, so we are calculating f for 2 kilo. So m into v. So we know the velocity of the mass of stand. The water velocity is not changing at all. So this will be 0. So velocity here is 5 meter per second into dm dt is 1 kg per second. This is 5 meter per second. Now, so this is for this thing is m into acceleration. Here we are talking about the 2 kg block. So this is 2 kilo into A, and F already we got 5 Newton. Here is 5 by 2 into SI unit, not into unit will be SI unit, which is meter per second square. This is 2.5 meter per second square. This is the initial acceleration block. So what we have done, we know that water is coming from that way. So acceleration would be in that way. F is equal to dp by dt, which is changing momentum. Momentum is mv. Here the momentum is changing because the mass of the block is increasing because of water, and step with the mass is increasing. So only this, and we put the value, we got the force, and then we know at like basically this, because of this force, this 2 kg is accelerating. So when we know the force, we can know what force is 2 kg particle is facing. So it will have an acceleration, and the acceleration is force by mass. And here we got 2.5 meter per second square. Times in exams, where this kind of graphs are given. So at one axis it is velocity, meter per second. Another axis is time. So for the simplicity, I'm drawing kind of so. The questions looks like this, that this is velocity and time graph. This is 4, this is 8, 10, 8, okay, this is 12. And then another graph will be there. At 2, the velocity is 8. So basically, the graph is that. So now the question is, question of the object between time t equal to 0 and t equal to 2 seconds. So acceleration is equal to pv dt. So basically v final minus v initial by v final minus t initial. So here it is 2 minus 0. Now we to know have to know what is v final and v initial. So v final is v at 2 seconds. V initial is
Hello.
v at 0 second.
Hello.
Hello.
Hello. Yes, ma'am. Good evening.
Good evening.
Ma'am, could you please suggest some books so that one could practice questions of this sort?
For Newtonian mechanics, whatever professor has suggested, or you can solve kind of competitive questions, competitive exam questions.
Okay, okay. No, no. I was asking like a proper text.
Yeah, but for proper textbook, I don't remember now for Newtonian mechanics, for Lorentzian mechanics and all those things. There are book I remember, but that will not help.
Okay, but how do you suggest Klepner, Kolenkov, as well as Morin's mechanics books?
That is also fine.
Okay, okay,
Kepler and Kolenko, if you can do that, that will be great.
okay, okay.
And
Um,
there is also the Lim series books, so you
which
can
series,
go
ma'am?
through
Which series?
Lim series classical mechanics.
Lim series.
Yeah,
LIM series.
yeah, Lim series. Yeah,
Okay, okay. Okay. Oh, okay.
and there is also Lim series. There is
Young,
also quantum
young cool
mechanics and
limb
all
like
those
that.
things.
Young cool
Yeah,
limb. Young cool
yeah,
limb.
yeah, yeah,
Okay.
yeah, yeah.
Okay. Okay. Okay, ma'am.
So if
Okay.
you want to practice, do practice those things.
Ma'am, like, do you have? Can you suggest some books for? For brushing up our maths fundamentals, like physics. Calculus and stuff.
Mathematical methods.
By whom, ma'am?
Like, do you want to know the book for mathematical methods, or like normal
Ma'am,
math books
ma'am, for brushing up this thing, brushing up the mathematical, machinery that you require for this course.
okay, so for vector calculation for Fourier series, I don't know if Fourier series is required and all those things, but for mathematical methods books, yes, Devmallu, if you need something.
Okay, ma'am, like for
Mathematical methods book for physics related book, not for only this course. If you go
okay,
for higher up physics and all those things, mathematical physics, there is like for vector analysis, you can go through the Schwamm series book.
okay.
And
Shram
also
series, which
there
one
is
in particular, ma'am? Which one in particular for
Schwamm series for vector analysis. That will
vector?
be enough for vector. And
Okay.
all mathematical methods book, you can go ML Boas,
No, no,
HK Das.
ma'am, ML boss is a little hard for me.
HK Das, you can go for HK Das. I don't know if HK Das book have PDF version available in online, but you can always buy one. It's a like thick book,
Ma'am,
and
like,
there is lot.
do you have
There
a
is
like
lot.
primer? Yes, ma'am. Do you have like a primer, like everything, like the basics they will tell, and also like what is required for
Yeah,
physics?
like there is lot of
no, no, like any
Like
particular book you do not suggest, ma'am. Any particular book, like one book, let's say, like which will have all the basics. Then after that, I'll be able to do these texts that you suggested.
basics for what? Mathematical methods?
Yes, ma'am. Calculus, vector analysis, let's
And
say.
then see, that's what I'm trying to tell you, that if for physics point of view, Mathematical Methods by H.K. Das is a good book.
Okay, 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 ma'am. Thank you.
There is lot of examples. You can go through that. But
Okay,
for only this course, you don't need that all the mathematical methods for physics.
okay, okay,
Okay.
okay.
You just need to know vector analysis and differential equation and all those things.
Okay, okay. Ma'am,
In
as you,
for
yes,
yeah.
yes, ma'am. Ma'am, like you said, the PDF isn't available. I just searched actually. Would you happen to have the PDF?
I don't have the PDF because I have completed my bachelor's a long time ago, and that time I happened to have the book.
Okay, okay. Okay, ma'am, if you could,
What question do you have?
pardon, ma'am?
Like you were asking that if I had the PDF of the book, or
Uh-huh.
what was your question if I had the PDF?
You could send note, then I could download it because it's not
No, I
available.
don't have the PDF. I don't know have the I don't know I don't have the PDF. That's why I told you that I don't know if the PDF is available or not. Like I had the book that time.
Okay, okay. Okay, ma'am, like could you search also, like, if it would be possible?
I can search now, but I don't think I have, like there is the book in the in the web,
Okay, okay.
because
Okay,
that's why I bought them.
okay, okay,
And
ma'am.
also a lot of year passed after that, but please search, and if I get on somewhere I will share.
Okay, 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 ma'am. Thank you.
Yeah. Now we need to know what is the velocity at, that is 8, and what is the velocity at t is equal to 0, that is 0. So we need to second square is the acceleration of the object. What is the acceleration object between time t is equal to 10 and t is equal to 12. In similar way, we need to know the velocity at 12 second, in 10 second. This is time is 12 minus 10, this is 2. Velocity at 10 was 8, and velocity at 12 was 4. So square minus 2 meter by second square. So velocity will be minus 2 meter by second square. Third part of the question is, what is the times t equal to 0 and v is equal to 16. So basically, v is equal to, we know dx dt integration. The integration means this x is basically curve of vt graph. So here we can see that we can break this area in three part. That part, which is a triangle. This is a kind of, okay, this is a square, kind of. This is a triangle. This is a rectangle. This is square. Here I did a mistake. Should remove these two lines should be equal space. That is my mistake. So here area, it is half of 2 into 8. But this area is 8 into 16. This is 8. This area is 24. Thing will get the area, and that is the answer. Basically, 16 plus 4 plus 24 plus 8. It is 20, 20, 44, 44 plus 4 is 44, 46, 48, 52. So this is the answer. So for this, you need to have like knowledge of integration, basically, nothing else. Moving with acceleration A is equal to alpha minus beta V, where alpha and beta are constant and V is instantaneous speed. Find the okay, velocity of a particle is a function of time and also find its terminal velocity. So where acceleration is given, so you need to find the velocity. So basically it's a mathematics problem, we know dv dt. So v is equal to a dt. But a is given like this. So we need to write it like this, otherwise we won't be able to integrate it. So it is 0 to v, it is 0 to t. So this side is t, there is no problem with that. This side, we need to make the integration. To make the integration, we need to take the common beta out of the thing. So the integration of v equals ln alpha minus beta v by alpha. Beta v by alpha is equal to t. Minus beta by alpha v by beta 1 minus e to the power tv. So when t is infinite, then we will get terminal velocity. So when t is equal to infinite, e to the power t v is equal to 0. So v will be only alpha by beta. This is terminal velocity. So this is a type of question which is basically a mathematical question, basically an integration, nothing else. You just need to know how to do the integration. There is no force acting and where it is acting and all those things. With a involving force, which is a friction question. Kinetic friction. And then there is static friction. Okay. So in kinetic friction, the things basically are sliding on a surface. So there is a force of N which works perpendicular to the surface. If it is moving and velocity is in that side, friction will work at that side. And friction will be, this is the coefficient of friction, and friction will be mu n. But for static friction, this is kinetic friction. For static friction, the system will not be sliding. But basically, n will be at the perpendicular direction of the surface, where v is equal to 0 and force frictional force F will be less than mu n, or it can be y. That is static friction. Now, question regarding this thing, because there will be friction in any question where force is involved. So you need to take that account also. So the question is, a block slides as I have mentioned that the call can be disconnected after 1 hour. So after 1 hour, you need to like join this like meeting. Block slides down and change action between the block and the plane is mean. Calculate acceleration of block. So we need to draw the diagram fast. How, what kind of forces are acting on the clock? So that is theta. These are very important kind of question. One way or another way, you need to get this kind of question. And basic thing is that weight is working in this direction. Okay, the n is working in this direction, that I know. We know. So basically, it is sliding in this direction, so friction will work in that direction. So acceleration is in this direction. So we need this mg thing, we need to break into component. This is theta. Mathematically, it is also theta. So this is mg cos theta component. This is mg sin theta component. So basically, n is compensated mg cos theta. And in like this direction, mg sin theta is working in this direction, opposite direction, f is working. This is ma. We know f is equal to n. N is equal to mg cos theta, which is equal to ma. So basically the equation is now mg sin theta minus mu mg cos theta is equal to ma. So we need to know the acceleration. So basically a is equal to g sin theta minus mu g cos theta. We can take the g common. This is sin theta minus mu cos theta. The next example is another test kind of question regarding friction. A block of mass m is pulled with a force F at an angle theta with horizontal. The block is not move on the surface. Calculate force of friction on the block and value of coefficient of friction. So we need to calculate F and mu. Okay, let's draw the diagram. This is the block. Same this way mg, this way n is working. So the block is not moving. So this is static friction. And the block is being pulled by F. So the pull will be at that direction with an angle theta. So this will be F cos theta. This will be F sin theta. So basically, all we have to do that all break all kind of force in two direction and then do the calculation. Here the two direction is x and y. But in this example, we can see the two direction is not x and y. The x and y axis, it is like kind of x and y axis are tilted. All the other things are good. But if we don't like to divide into the components mg and rather we go to the f to divide into the components of x and y and n into x and y, the result will be the same but calculation will be the difficult. So f is equal to f cos theta. You can write sometime fk or fs to denote it is static. So this is fs. F sin theta is equal to mg. And we know for static friction Fs is less than Mn. So we know what is N. N is equal to mg minus F sin theta. So this is Fs mu into N. N is equal to mg minus F sin theta. F S, which is static friction, is basically F cos theta. Put that into this thing and mu into. So F cos theta is less than equal to mu mg F sin theta. So mu mg F cos theta mg minus F sin theta. And also we have it today. Now move to the another kind of questions. So for example 7, that a block of mass to a light spring smooth horizontal shown in figure. Horizon if is applied to the block. Calculate maximum speed of the block. So calculate what happens. Block accelerates, then it get 0. Then acceleration becomes 0 and ultimately negative, because that's when stops. Speed of the clock is the maximum and acceleration was so is equal to 0. That means f is also 0. So f in these things, that is, f is working in that direction. So f minus kx equal to 0. That means x is equal to f by k. Now, we can say when speed is maximum, elongation in spring, motion in spring is equal to f by k. Now, to find maximum speed, we need to use the work energy theorem. So, to kind of work. That's work download force. And kinetic energy is since half of mv square along with it. Then that this belongs to f0 to f by k, and this is also from 0 to f by k. So after integration we get square by 2k plus f square by k into half of mv square. So v is equal to f square by mk. X0 is the maximum elongation. elongation. When elongation is maximum, we already know that log comes to 0. So yeah, again, work energy theorem. So basically, W spring, the spring was work by force equal to now 0, 0. Again, the same thing. Where the unit is from 0 to x naught. And then minus half of k x naught squared plus f x naught. So x naught will be 2f by k. And this is the maximum elevation. So basically here, first we need to assume that when acceleration is 0, then the block is speed of the block is maximum. So when acceleration is 0, the x is up to f by k. Then we go to the work energy theorem, that work done and changing kinetic energy when there is maximum speed, which is v is not equal to 0. So half of mv square will be there. Then we simplify the equation, we get v is equal to f squared by mk root over under root. And now that elongation is maximum when v becomes 0. Then the same equation with the right hand side 0. So you get the elongation. That is 7. Now, example 8. question, then I can read it at once. But initially kept picks up into three fragments of mass ratio 1:2:3. Note what is speed of lightest fragment. So the material has broken into three parts, one, two, three. The heaviest fragment has speed v naught after the explosion. Now we need to know that what is the speed of the lightest fragment. It is given that three fragments move in the same plane and make equal angle with each other. Momentum conservation. All these examples boil down to one thing, Jim. You need to like draw the diagram and what other the forces are working on the system. So basically, we can say that here the fragment was at rest, not the fragment, the object. So we conserve momentum. The vector sum of all the momentum also 0. So let us assume that sets of fragments are real, not real. Okay. Mm. So they have moved in all equal direction. So let us assume this is n and equal direction, and there is a 360-degree direction. So all moves in equal direct, or the angle between all those three are equal. So maybe this is 2 and this is 3 and the angle this is 120 and this is 120 as well. So this is 120 degree. This is 90. This is 30. So it will be 60. And this is also 60. So all the components we need to break in x and y direction. So in x direction, is going the 2n v x direction is going in this direction, negative x direction, and also same for the 3n. So you can see that in v minus this is v1, this is v2, this is v3. Oh no, oh no, they have already said that is v1. Here is that now. So v1 to v2 cos 60 degree minus 3 and v0 for 60 degree is 0. So the simplification we got v1 minus v2 is equal to 3 v0 by 2. And in y direction there is no movement, or you can say that each one is balancing the other one. So u and v1 sine 60 degree is equal to 3 and v0 sine 60 degree. And here we get a relationship between okay, is not v minus v2. V2 will go to 3 v0 by 2. So v1 minus v2 is equal to 3 v0 by 2. v1 is equal to v2 plus 3 v0 by 2. So it is that it is that way anyway. So you can say V1 is equal to 3V1. And we were asked to like uh, measure the V naught only, that the lightest particle. I previously mentioned that P is equal to linear momentum. Angular momentum, which is denoted by L. Angular momentum is on R equals to. The R is very important. That question is that a particle repeatedly is moving such that time actually in meter is given by to 5I minus 2 is equal to the angular momentum of the particle at t is equal to 2 seconds about the origin in kg meters per second inverse is. So we need to know the angular momentum. I have already told what is the like equation. So L is equal to R cross P. R is equal to 5I, that is equivalent to X. So R is that, basically it is 8 feet. This thing is constant. So we will get only for a teacher. So it will be minus 8 dy L is equal to R cross P. 5x minus 2t squared j minus 3 equal to 0, we will get x cross y, which will be minus 40 t x cross y, which is minus 40 t z. So t equal to 2. So minus 40 t of t, we put 2 seconds. So minus 82. This is the angular momentum. Another great question. After rainbow accumulates moisture due to which its radius increases at rate a. Their track calculate the speed of rate of the people's Poland. It has for a time. So the equation of motion, yeah, Given that the rate of increase is great, so once it change the control of volume into density. To energy. So it's zero. Putting this boundary value, we take the value of c. Okay, so going to G by 4. Okay, so 5, yeah, is equal to G by 4. That's 8. Not Thursday, this Tuesday. Thank you. Thank you for attending the class.